In this video, we'll look at question 50 from the 2016 exam.
So in this question, an object of mass 20 kilos is pulled up a rough plane, which is at 30 degrees to the horizontal. We know that it has an acceleration of 2.5 meters per second, and it is attached to a rope, which goes here around a pulley at the top, and the other end is attached to a load of 30 kilos. We are supposed to find the force of friction between the block and the incline.
So let's just have a look at our diagram and try and draw in some forces. So, well, the first force which comes to mind is force of gravity, acting on both of the blocks, 300 newtons and 200 newtons, like this, 200 newtons. And this angle of 30 degrees also has to be here, 30 degrees. So the projection of the force of gravity into the direction of the incline is now 200 times sine of 30. And because sine of 30 is 1/2, this will be just 100 newtons. Acting in the same direction is, of course, also our force of friction, which we are supposed to find. And in the opposite direction, a tension in the rope T, the same as here and everywhere along the rope. Given all this information, can you find the tension T? And because the black block also has to move with the same acceleration, 2.5 meters per second, we can write a statement of Newton's second law, which says that the mass times the acceleration must be the resultant force of the two, the red one and the blue one. And when we evaluate the expression, we get 225 newtons. So that's our tension. And now when we look at the white box alone, we see that there are three forces acting on it. Tension 225 to the right, there's a projection of gravity pulling downwards, or to the left in this diagram, 100 newtons, and the force F, which we are trying to find. One other thing we know is that this whole box will have to move to the right with this acceleration. So once again, we can write down Newton's second law as mass times acceleration is the resultant force of these three, 225 to the right minus 100 minus F. And again, that's a linear equation in F, so we can express F in terms of the numbers, which gives us 75 newtons. So that's the final answer for the friction between the block and the incline. And in the exam, it was option C.